Welcome to our quantum deep dive. Today, we're exploring the work of a scientist who is, well, pretty much building the 21st century from the ground up, Mikhail Lukin. Yeah, this explainer is based on a really detailed essay by Jörg O. Schneepatt, and we're going to break down how Lukin is constructing the machines of the future, literally one single atom at a time.
You know, this quote just perfectly nails Lukin's unique contribution. He's not just a theorist, lost in a world of equations, or an experimenter just tinkering with gadgets. He's the bridge between those two worlds.
Exactly. He's one of those incredibly rare physicists who doesn't just understand the deepest mysteries of quantum mechanics, but as the source essay puts it, he can actually shape it with his own hands.
Right, it's a huge question, and it's a journey that starts with some really fundamental ideas about light and matter and ends with technology that could change everything. Okay, let's dive into this. So Mikhail Lukin is, without a doubt, one of the most influential people in modern quantum physics. I mean, as co-founder of the Harvard Quantum Initiative, he's been at the center of it all, shaping the scientific agenda for more than 2 decades now. His work has really become a cornerstone of the entire field. He's really at the forefront of this massive quest to control these hugely complex quantum systems. And his research, especially with things like Rydberg atoms and neutral atom qubits, and don't worry, we are absolutely going to break those down in a minute, that research has gotten worldwide recognition. It's paving the way for practical, scalable quantum computers. You know, to really get his work, you first have to understand his journey. And that story began in a country with this incredibly powerful, centuries-old tradition in theoretical physics. So his path took him from this super rigorous theoretical training at the MIT, which is a really elite scientific institution, all the way to the cutting-edge experimental labs in the US. And this created this powerful fusion of scientific approaches. You've got the deep theory on one side and the hands-on building on the other. That combination really defines his work even today. Okay, so this phenomenon, EIT, it became the absolute foundation for all of his later breakthroughs. The easiest way to think about it is like creating an invisibility cloak for atoms. By using lasers in a really, really precise way, scientists can make a material that normally just soaks up light completely transparent.
And that gives them this incredible level of control. It actually lets them slow down light and even stop it in its tracks. And that ability, it's a key ingredient for building future technologies like quantum memory and enabling truly secure quantum communication.
All right, so with this new power to control how light interacts with matter, Lukin turned his focus to the atoms themselves. See, if you want to build a quantum computer, you need your quantum bits, your qubits, to be able to talk to each other to perform calculations. He had to find a reliable way to make that conversation happen. And Lukin's key insight was to use something called Rydberg atoms. These are basically just regular atoms that have been excited into a giant puffy state. A laser zaps an electron, pushing it into the super high energy orbit, and the whole atom just swells up, thousands of times its normal size. Now, this massive size difference is absolutely crucial, because these giant atoms interact very, very strongly with each other, even over relatively long distances for an atom. And this super strong interaction leads to this brilliant effect called the Rydberg blockade. Honestly, the best analogy is to think of it as a mandatory social distancing rule for atoms. If you excite one atom into that Rydberg state, its energy field gets so huge that it actually shifts the energy levels of its neighbors, and that blocks them from being excited by the same laser pulse. So one is on, and the others nearby are forced to stay off. So the really crucial point here is that this blockade isn't just some neat physics trick. It is the physical mechanism for a quantum logic gate. Specifically, it creates what's called a CNOT, or a controlled NOT gate.
Right. And what that means is the state of one atom, we can call it the control atom, directly determines what happens to a second atom, the target atom. It's this simple, powerful if-then relationship. And that relationship is the absolute foundation of all computation, and now it's been perfectly translated into the quantum world.
Okay, so how do you get from a single 2-atom logic gate all the way to a full-blown quantum processor? Well, with that crucial building block figured out, Lukin and his team began the really painstaking work of assembling these atoms into an actual computing device. What they built was this incredible new kind of architecture. They use highly focused laser beams called optical tweezers. You can literally picture them as atomic tractor beams that can grab and arrange individual rubidium atoms in a perfect grid. Each one of those atoms is a qubit, and the Rydberg blockade provides the logic that connects them all. And the real beauty of this whole system is just how flexible it is. You can literally move the atoms around and reconfigure the entire processor on the fly. It's amazing. And you can see the power of this approach just by looking at the incredibly rapid progress. In just a few years, his lab scaled their systems from dozens to hundreds of qubits. They even created these complex Schrödinger cat states, which is where a big group of atoms exist in that really weird quantum superposition of being both on and off at the same time. And let me tell you, that is a key and very difficult test for any real quantum computer. By 2021, their processor hit this number: 256 fully controllable atoms. This milestone, which was detailed in the journal Nature, wasn't just about getting bigger. It really represented a tipping point. It allowed them to simulate complex quantum materials at a scale that was never before possible, exploring all this exotic physics that you just can't calculate, not even on the world's most powerful supercomputers. But Lukin's impact doesn't just stop at the lab bench. He's been absolutely instrumental in creating the entire ecosystem that you need to turn these scientific breakthroughs into real-world revolutionary technology. Yep, back in 2018, he was a major driving force behind the Harvard Quantum Initiative. It's this powerhouse interdisciplinary center that brings together physics, computer science, and engineering, creating a hub to accelerate quantum development and, just as importantly, train the next generation of scientists. And his expertise is sought at the absolute highest levels. He advises the U.S. government on its national strategy for quantum technology. We're talking about helping direct billions of dollars in funding and research priorities to keep the country at the forefront of this global race. And he's taking this technology directly to the market. Lukin co-founded Quera Computing. It's a startup that is building the very first commercial quantum computers based on his neutral atom architecture. It's a direct translation of his lab's fundamental research into a real industrial-strength machine. Beyond the institutions, his legacy is really carried by people. So many of his former students and postdocs are now leaders in their own right. They're heading up research at top universities like MIT and ETH Zurich, they're driving discovery at major research centers, and they're founding the next wave of quantum companies all over the world. He's building not just computers, but an entire community of innovators. This really just sums it all up, doesn't it? He's one of those rare scientists who can not only grasp the deep, abstract theory of quantum mechanics, but he can also see the direct path to building a machine that actually puts that theory to work. It's that dual perspective. Seeing technology and theory as two sides of the same coin, that's what makes him such a pivotal figure in our time. So his work has given us the hardware. The tools are here. And now the challenge really passes to all of us to imagine what problems in medicine, in material science, finance, even artificial intelligence, what problems can we finally solve with these powerful new tools?
And that concludes our explainer on Mikhail Lukin, which was based on the essay by Jörg Owe Schnippat. Thank you so much for joining us. For more, please visit schnippat.de. Goodbye.
Schnippat.de is a private project by Jörg Owe Schnippat dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.